Disclosure: this educational content has been developed using artificial intelligence.
Ever wondered how a baseball flies through the air? Or how planets orbit the sun? For centuries, we had a set of rules that described our world perfectly. This is classical physics. The physics of Isaac Newton. It's predictable, intuitive, and it governs everything we can see and touch in our everyday lives. Think of it like a game of billiards. You hit the cue ball, it hits another ball, and you can calculate exactly where each ball will go. Simple, right? But what happens when we zoom in? I mean, really zoom in. Smaller than an atom, that's where things get wonderfully weird. Welcome to the realm of quantum physics. Down here, the familiar rules of our big world break down completely. Imagine that billiard ball isn't in one place anymore. Instead, it exists as a wave of possibilities, a cloud of potential locations. It's only when you look at it, or masurit, that it suddenly chooses a spot to be in. Strange, isn't it? This is called superposition. In classical physics, a cat is either alive or dead. But in a famous quantum thought experiment, Schrödinger's cat can be both alive and dead at the same time, until you open the box to check. Another mind-bending concept is entanglement. Imagine you have two particles that are linked. If you measure a property of one particle, you instantly know the same property of its partner, no matter how far apart they are, even if they're on opposite sides of the universe. Einstein famously called this spooky action at a distance, because it seems to defy the rule that nothing can travel faster than light. In the classical world, if you have two sealed envelopes, opening one tells you nothing about the contents of the other. In the quantum world, it's like opening one envelope instantly reveals what's inside its distant twin. So, what's the core difference? Classical physics describes a world of certainty. If you know the starting conditions, you can predict the future with absolute precision. It's deterministic. Quantum physics, on the other hand, describes a world of probability. We can't say for sure where a particle will be, only where it's asterisk likely. Asterisks to be. It's like predicting the weather versus predicting a coin flip. With enough data, we can be pretty sure about the weather forecast. But for a single coin flip, it's always a 50/50th chance until it lands. You might be thinking, this is fascinating, but what does it have to do with me? Well, this weird quantum science is the foundation of our modern world. The computer or phone you're watching this on. It works because of quantum mechanics. The transistors and microchips inside are built on our understanding of how electrons behave at the quantum level. GPS, lasers, MRI machines. In hospitals, they all rely on quantum principles. So, while classical physics built the world we see, quantum physics is building the world of tomorrow. In a nutshell, classical physics is the beautiful, orderly story of the big, visible universe. It's the physics of planets and baseballs. Quantum physics is the wild, probabilistic, and often counterintuitive story of the infinitesimally small. It's the physics of atoms and particles. They aren't two competing theories. They're two parts of the same, grander story of our universe, each ruling its own domain. One describes the majestic forest, the other describes the strange and magical life hidden in a single drop of water. And by understanding both, we get a much richer picture of reality. Thanks so much for diving into this fascinating topic with me today. If you enjoyed this journey from the classical to the quantum, don't forget to hit that like button and subscribe for more explorations into the mysteries of science. See you in the next video.